Civil engineers are in the forefront of technology. They are the leading users of sophisticated, high-tech products, applying the very latest concepts in computer-aided drafting during design, construction, project scheduling, and cost control. Civil engineering is about community service, development, and improvement. It involves the conception, planning, design, construction, and operation of facilities essential to modern life, ranging from transit systems to offshore structures to space satellites. Civil engineers are problem solvers, meeting the challenges of pollution, traffic congestion, drinking water and energy needs, urban redevelopment, and community planning. The American Society of Civil Engineers, also known as ASCE, has contributed to the development of many outreach programs to encourage young students to consider careers as engineers. These include the West Point Bridge Designer Program, the Zoom series, and the Building Big series on PBS. In Seattle, the younger members of ASCE conduct the annual Popsicle Stick Bridge Building Contest for students. The contest is sponsored by the local engineering community and was first held in 1996. Each year, the contest is held in conjunction with the National Engineers Week festivities in late February. The objective of the competition is to give students an opportunity to learn about engineering principles and careers in engineering by interacting with practicing engineers in a fun and educational setting.
I think the primary thing is they've learned how to cooperate with one another, how to build off their strengths from one another, how to design a structure from start to finish using specific rules, which you guys change every year, which keeps us on our toes. You know, it challenges the kids. They get challenged every year. In fact, they get so excited about, they want the rules the first day back in September. They want the rules now. You know, they're ready now to start doing it. But they meet every week. They learn a lot about engineering, a lot about stress and strain and structures and all different kinds of engineering and physics concepts.
Several months before the contest, civil engineers visit high schools around the Puget Sound region and present the fundamentals of basic engineering and bridge building. Using the lessons learned from these classes, the students build bridges out of popsicle sticks and white glue using their creativity and engineering design principles. Students must use everything they have learned about bridges to satisfy a combination of judging criteria, including the strength of the bridge and the overall look of the bridge. During the contest, each bridge is judged on the basis of aesthetics by a panel of experts in the field of engineering and architecture. The bridges are then loaded to failure on a load test machine as the students watch their hard work go to pieces. Prizes are awarded for the bridge that best satisfies all of the judging criteria.
This year I was the chairperson of the Rules Committee, which means that we go through the rules and change them as required to create a little bit more of a change from last year, so every year is not just the same as the year before. And this year I was also a technical judge.
I organize both the technical judges and aesthetic judges, and what we do is we qualify all the bridges before they're load tested and judged, and they can be awarded prizes to make sure every bridge meets the same criteria so that all the students are on the same playing field, so that no bridge is any different than the others that didn't meet the rules. So it's our job just to look through, make sure they met all the criteria that the Rules Committee set out to make.
This year, the only thing that the bridges got disqualified for is that they're actually too short. We have a specific length requirements, and if they're too short for that, it's not fair for the other schools that actually did read that correctly and made their bridges long enough. In past years, pretty much the hardest thing to change a lot of times is the dimensions. And occasionally we also have problems with some of the gluing between the members.
The aesthetics judging, we usually get outside architects or artists from the design community, since we really want to separate those and not have the technical judges doing the aesthetic judging also. And it's more of the how nice everything is glued, is it clean, and the overall appearance, and did they put in an extra effort to make their bridge look more beautiful than the other school's bridge. Just not bridges in design are not only have to support the loads that we drive across if it was a real bridge, but have to be pleasing to the environment that they're in. So it really pushes the students not only to build a stout bridge that can hold the most load, but come up with something creative to make it look beautiful. And that's what the judges really look at. So as you may have saw the bridge that holds the most weight isn't necessarily the overall winner, because we want them to be the most beautiful, the strongest, and the best estimated load guess, which is another criteria that they're judged on.
This project teaches students how to work together as a team in constructing a strong yet aesthetic bridge. This interaction provides practical training for real-world teamwork in any path the students may choose to pursue. Teamwork, communication, math, science, competition, ingenuity, and creativity are all tools which will help create strong and intelligent leaders and engineers for our future.
Today I was the overall winner of the competition. My bridge broke, it had a catastrophic failure. I had supports underneath and they all busted out at the same time, so that's how it broke. My advice to the future builders of Popsicle bridges is build them as early as you can and don't procrastinate. Just get them finished as soon as you can. That'll give you time to change any problems that you have on your bridge.